Section 5 of Chapter 2, looking at equations of lines and linear models. Linear is just talking about lines, y equals mx plus b, slope-intercept form, right, or point-slope form, or standard form. Those are all linear equations, right? So we're going to be looking at those. We're going to be writing equations based on either a point and a slope, or 2 points, or knowing a point and another equation that's perpendicular or parallel. Okay, so here's the first problem. Here's the first sample. We want to write an equation of a line that passes through a certain point at -3, 2, and with a slope of -2 in standard form. So that's a biggie that it's in standard form. Okay, so we're given a point and we're given a slope, right? So that would be a key to think about which form: standard form, point slope form, or slope intercept. One of those three we have to start with. We know eventually we're going to get here at standard form, but which form do I go to first? And because it gives us a point and a slope, we're going to start with point slope form, which is y minus y1. That's the y value of our point, equals our slope times the quantity x minus our x value, x1, of the point. So we start with point slope form, then we're going to move to standard form. And standard form is just putting your x's and your y's on one side of the equation and your constant on the other, and making sure you don't have any fractions or decimals or negative x's. Okay? Alright, so let's get going. This first y stays the same, right? And then I'm subtracting my y value, so it means I'm subtracting 2. I have my slope, which I'm given, -2, and then times by the quantity x minus my x1, which is a -3. So I'm minus a -3. So I need to start simplifying. Right? I can distribute this -2 to both of them. So this becomes -2x, and then here this is going to turn to +3, right? Plus 3. And then -2 times a +3 is a -6. Now I'm just going to move my x's to one side and my y's to the other. Okay, so we can move this over here. So we have 2x plus y, because it's a positive y, so we'll put a plus y, minus 2 equals -6. Move this to -2 to the other side by adding, and we get 2x plus y equals -4. Okay, and boom, we're done. Now it is in standard form. We have our x's and y's together on one side, our constants on the other side, and we don't have any fractions or negative x's. Okay, so we're done, and you could check this, right? So one way to check would be to plug in that point, right? Plug in this point, -3, 2, or at least plug in just one of those values, right? I could plug in I could plug in -3 in for my x. Oh, why did I put a 3 there? It doesn't go there. So -3 for my x, and see if my y is 2, right? Just to check. So -6 plus y equals -4. Add 6 to both sides. Hey, look, y equals 2. That's true. So that was the correct equation. Okay, if you want to, you go ahead and pause the video and you could try this problem. Right? We're asked to write an equation of a line that's just, and here it says just write an equation of a line, so I can write any equation. I could go standard form, I could go slope intercept, I could go point slope form. It doesn't say which form I have to do, so you get to pick any one you want. Okay, and then they give you 2 points. So we have 2 points, and we're trying to write an equation of a line. So if you want to try it, go ahead. If you get stuck, you could start playing the video until you get stuck and then finish it. Okay. Here we go. So I have 2 points. So I don't have a 2-point equation. It doesn't say these 2 points write this equation, right? But we do have a point slope form. So when I do have my choices, I could pick this point, point number 1, or you can call it point A, or point B, right? So it doesn't matter which point I call it. Point. So it doesn't matter which point I use. But I need a slope. Well, how do I find the slope between two lines? Isn't that my rise over run? So my slope, which is m, would be the difference of my y's, y2 minus y1 over the difference of my x's, right? I rise with my y's, y, and I run from my x's, rise, run. Okay, so my y's are -4 and 1. What's the difference between -4 and 1? -4 minus 1. Okay, so that's -5. And then my x's, now since I started with -4, that means I have to start with 3. I have to start with 3. So 3 minus a -2, that's a +2. So I get 5, so I get -1. So my slope is -1. Oops, equals -1. Okay, so now that the slope is done, now I have any point I want to. I can choose any point. Let's choose the first point. So y minus my y value, which is 1 of that first point, point A, and then equals my slope times x minus my x value, which is a -2. Now I can just simplify this. Y minus 1 equals -1 times x plus 2. So there's point slope form, right? Okay, I can stop there because I'm done. It said just write an equation. Here's an equation of a line. It's in point slope form. It didn't ask me what form. Or I could keep going. I could distribute that. Okay, and then I could solve for y. I could get y by itself. So y is equal to -x minus 1. Boom, that's in. So this is point slope form because I have a point, -2 and a +1, and a slope -1. Here I'm in slope intercept. My slope is -1 and my y-intercept is -1. Or I could put it in standard form by adding x to both sides. So I get x plus y equals -1. So there's standard form. So I have point slope form, I have slope intercept form, and then I have standard form. It didn't ask which form, so I could do any of these. Okay, so write an equation that is through a point 2, 5, and parallel to this equation, right? So this equation is some line, right? It represents a line. And I want to write another equation of another line that passes through this point 2, 5, right? So I want the equation of this line. This line in green is this one, but I want the one in red where it's parallel. Parallel means these don't cross, right? So what that means, parallel, in terms of writing an equation, is parallel means same slope. Okay, so I'm going to steal the slope of this equation, and I'm going to use it with this point to write the equation of this line. Okay, so here I have to steal the slope of this equation. So that means I got to find what form is it now in, though. The form that it's in currently is standard form. Well, standard form doesn't give us our slope, so I either put it in slope intercept, which means solving for y, or I need to put it in point slope form, which from this is more complicated, so you don't need to do that. Just solve it for y, right? So if I solve that for y, 3x plus 4y equals 5, I would just subtract 3x. And really, I mean, I don't even really have to even pay attention to that 5 there, because my slope in slope intercept form, y equals mx plus b. That b has nothing to do with my slope, the m. What's the coefficient in front of the x, or how many x's do I have? Right, that's all I care about, really. Because all I'm after is the slope. I'm just stealing the slope. And I like how I spelled, oh, I did spell steal right. Nice. Okay, so then I need to get y by itself, because it's y equals, so divide everything by 4. That includes this and the 5, but the 5 really doesn't matter, because I don't really need it, because all I'm doing is taking the slope. So y equals -3/4 x plus 5/4. And all I care about is what is that number in front of the x. What's that coefficient? -3/4. There's my slope. So now I have a slope, -3/4. So then I come back to my point that it says 2, 5. And a point 2, 5. Notice again that it just says write an equation, right? It says write an equation. That means it doesn't matter what form. It's not asking for a form. It's just asking you to write an equation. So the best one would be slope point. or point slope form. Y minus y1 equals m times x minus x1. Okay, so I enter my point in. Here's my y1, 5. So y minus 5, my slope, which is negative 3/4, times the quantity x minus that x1, which is 2. So minus 2. Hey, look, I'm done. Stop right there. Don't go any farther. You don't need to. If it asks you to put it in standard form, then you distribute that. Negative 3/4 to both of them. Put x and y on one side. Make sure you have no fractions. Sure, I'll go ahead and do it. What's that? Positive 6/4, which is 3/2. Alright, so positive 3/2 here. Okay, so this one, it's a good practice to put it in standard form. So I want to move my x's over. So 3/4 x plus y minus 5 equals, here, I'll do it right here. Move it to this side. Okay. Equals 3/2. Okay, add 5, add 5. 5 is the same thing as 10/2, right? So 3/4 x plus y equals 3/2 plus 10/2. Okay, so 3/4 x plus y equals 13/2. Okay, now if I have it in standard form, I cannot have fractions. So I multiply by the largest denominator. It's one way to do it. Multiply by the largest denominator. Or multiply by the greatest common factor. Okay, so that'd be 4. So I multiply everything, every term by 4. So here the 4's are going to cancel out. I get 3x left. Here the 4's are not. I'm just going to get plus 4y. Here the 2's going to cancel out 4, but I have a remaining 2, and 2 times 13 is 26. Boom, there's standard form for you. Okay? And then if I want to put it in slope-intercept form, I would just solve this for y. Get y by itself, right, would be negative 3/4 y, or just 3/4 x, and then plus 26 over 4 is equal to y. Right, so there it is. So there's that one. Point slope form. We already really did point slope form. It was pretty much right here. That was kind of our point slope form. Okay, so but you can leave it in any of those 3 forms. It wouldn't matter. Right? If it says to put it in one form, then you need to put it in that form. But if it doesn't actually say which form to put it in, you can put it in any form. Okay, now we want to write another equation through a different point, negative 1, 2, so, and perpendicular to this line. So here's an equation for a line, so that represents some kind of line. Okay, there it is. We have another line, but it's through this point, negative 1, 2, and then it's perpendicular, so we want this line, right, and it's perpendicular to the green one. What perpendicular means, when we're writing an equation of a linear line, linear line, just a line, would be opposite reciprocal. Opposite reciprocal slope. Okay, what that basically means is we find the slope from this line, so we're still going to steal this slope. Slope. We're still going to steal the slope, and then all we're going to do is flip the fraction. Flip fraction. If you don't have a fraction, if you just have a whole number, put a 1 underneath it, right? And then flip the fraction and change the sign. That's basically what perpendicular means when we're talking about this. Change sign. Okay, so let's go ahead and steal this slope. 2y plus 3y equals 5. So you notice this standard form has a positive x and no fractions, right? That's how standard form always has to be. Okay, so let's go ahead and steal it. That means we need to put this in slope-intercept form, so we subtract 2x, Really, I don't care about that 5, but for all purposes of practicing, Go ahead and leave that in there. Divide everything by 3. That is including the 5, even though we really don't care about it, because all we care about is the coefficient in front of the x, negative 2/3. So that is our slope. So our m equals negative 2/3. Okay, so what we're going to do, we're going to flip this fraction. So 3/2, negative 3/2. Then we're going to change the sign. So our perpendicular slope is 3/2. So that's the slope that we're going to use for this new line. And the point that we have is negative 1, 2. Okay, so the point, negative 1, 2. Okay, so go ahead, you can pause the video now. Now write an equation. Good practice. Here you have a point, and you have a slope. Write an equation. It didn't say which one, so put it in point slope or point slope form. Okay, pause the video because I'm about to do it. Y minus 2, so I always subtract the y value, equals my slope, the perpendicular slope, 3/2. X minus my x value, that's a minus and a minus 1, so that's going to turn to a positive 1. Okay, so I'll clean that up so it looks a little nicer. Now it's a plus 1. So there, boom, you are done. Okay, good practice. If you did that, great. Go ahead and change this to y-intercept. Okay, slope-intercept form. Okay, that would be distributing the slope. So you get 3/2 x plus 3/2 equals y minus 2. Now add 2 to both sides. When I'm adding 2, when I add 2 to both sides, so I add 2 over here. When I add 2 over here, I'm actually adding 4 over 2, right? Common denominator. So that would be adding 7/2. And boom, there you go. So you could literally stop right here. Right? If it doesn't ask you for what form, then stop right here. Don't do any more work than you need to. Right? But if it says put it in slope-intercept form, then you need to take it one step farther. Distribute the slope and solve for y. If it says put it in standard form, then I got to move my x's over. So notice here I have a negative x now. So here now I have a negative x. Still plus y equals 7/2. So I got to get rid of that negative and the fraction. So multiply by the greatest common denominator, which is 2. But I got to get rid of this negative, so multiply by negative 2 on everything. Okay, both sides in every term. Okay, so that becomes, these 2's are going to cancel with that negative, and I just get 3x. Negative 2 times y is a negative 2y. And the 2's cancel, but I have a negative, so that's negative 7. So boom, your x is positive, and you have no fractions. Okay, always got to have that in standard form. And you can check this by, again, plugging in that point. Plug in negative 1 for x. I get negative 3. Add 3, I get negative 4. Negative 4 divided by negative 2 is a positive 2, right? I had the point negative 1, 2. So it is correct. Okay, now we're going to look at linear models. Linear models is just looking at data points, looking at information, and seeing that they represent, all those data points represent a linear model, a line, right? So I have some kind of, I'm doing a representation, I'm comparing two things, right? Some variable and some variable, right? And they have data points, okay? And they might look like that, right? It might be months and a year, months and degrees, right? Okay? So then this looks like, even though this data point's not a line, it almost looks like a line. So that's why it's called a linear model. Linear meaning line, and it's a model that looks like a line, right? And it helps us do, it helps us make predictions about, well, what about at this time? At this time, what's the degrees going to be? Okay, a linear model is just a collection of points that are best represented by a line. Okay, so a collection of data points that when graphed, they look like a line, a linear equation. So if they ask you to come up with a linear model, basically they're just asking you to do what we just did. Write a linear equation. Right, write an equation. It doesn't say what form, so I can do point slope form, slope intercept, or standard form. Okay, so here we're given the date, the time, and date, right, and the population. Okay. probably in millions. So in 1987, the population of the United States was 156 million. Okay, and then 1998 it was 175 million. They want to know, well, come up with a linear model that represents the time or the year and the population. So it's time in years, right? Okay. So this would just be our x, and this would be our y. So here are 2 points, right? So we're given 2 points, 1987 and 156. We're given 1988 and 175. It's just 2 points on the data. Okay, 1 point here and 1 point here. Right, this is 1987 and this is 1988, and here is 156 and here is 175 million, right? And they represent some kind of line. So then we could write an equation, a linear equation that we could go ahead and estimate or predict, okay, what's going to happen in the year 1993? And then, hey, oh, the population is going to be out here at 200 million something. Okay, so we use these linear models in real life. So here's a real life application to predict what's going to happen, right? When we're comparing 2 variables, what's going to happen in the future if we can have a linear model. This usually happens in statistics when you're talking about correlation between 2 variables. Usually correlation happens when there is some kind of linear relationship between them. So here we have 2 data points, so we have 2 points. So we can't write it in any form right now because we don't have an equation for 2 points, but we have an equation for a point and a slope, so I need to take these two and find slope. And slope is y2 minus y1 over x2 minus x1. So here's a little bit bigger numbers, but that's okay. Don't let bigger numbers scare you. They're numbers too. So we have 175 minus 156 over 1998, 88, sorry, minus 1987. Right, so this would be 1 point, this would be the second point. Again, you could switch those two sets, the denominators and numerators around, and that'd be fine, right? But I can't mix it up. If I start with 175, then on the bottom I'd start with 188 or 1988. If I started with 156, then I would start with 1987. Okay, so we can go ahead and solve this, but that's 21 or 19, sorry. So 19 here and over 1, so 19. So my slope is 19. So now I have a slope 19, and now I can use any one of those points. I can use the 1988 and 175. I can use that point. Now we can write our equation. Y minus y1, 175, equals my slope times x minus x1, 1988. Or you could use the other point, it wouldn't matter. Okay, here most likely you could leave it in this form, which is fine, but usually once they ask you to write a linear model, then they say, okay, what's going to happen in 1993? Okay, so then this 1993 represents years, right? Wasn't that our x? So then I would take this 1993 and plug it into here and then solve for y. So most cases you can leave it in that point slope form, but you'd probably want to solve it for y just because probably another question is going to be to ask you to enter in an x and solve for y. So you'd probably want to put it in slope intercept form, but it's not necessary here because you could still just do it, right? So if you wanted to, you could move that over. You multiply 19x minus 37772, and then we would add 175 to that, and then we would just move that over. We would add that together. Okay, so then if we add those together, then we get here that either equation solve for y. So this is just, if it's solved for y, it's a little bit easier just to plug in x right here rather than in the first one right here. But it wouldn't matter, okay? Because you'd still solve for that same answer. Okay, so here are the problems that I wanted to work on. I like how I didn't even put a page number here, but it should be on the board. Here, let me find it for you. Okay, so it's on page, sorry about that, page 226. Those numbers right there. Okay, so hey, remember, right? If you're having problems, um, send me a message on Edmodo. Let me know where you're, having trouble. I can respond to you, right? Or I can make another video about going through these problems or any other problems that are coming up. Okay. Make sure you can help one another too, right? You just can't help each other on quizzes or tests, but you can help each other with these assignments, right? Also, I know this video is a little late coming out, but I would like you to watch and take notes beforehand, right? So then you have time in class to help one another or send me a message so that I can reply to it. Okay.